welcome to our first hardware meetup in Wellington. I'm Mikayla Stokes, I will be your host today. So can anyone put up their hand if they've been to a hardware meetup before? And we have one, we have two, we have 3, 4, 5. This is a lot more than I was expecting, so that's great to hear, especially considering we haven't done an event here before. So if you haven't been before and you don't know what we're all about, we've been running since 2016 and we're all about bringing people together to showcase amazing companies working in different areas of the hardware space. So we've been running for quite a few years now. We couldn't be running this event without our amazing sponsors.
So Outset, look, I guess where it's well known now is we had the likes of Rocket Lab that started in Outset. And we've had LanzaTech, which is now $1 billion company on the New York Stock Exchange. And what's happened with Outset, it's sort of morphed over the years to become a deep tech hub for startups that are developing stuff that's where there's some real science challenges, and that's what we call deep tech. And so they've got a facility up there. There's about, I don't know, must be about 15 to 20 companies that are based there now. And the good thing with Outset is that it's not like a shared office sort of thing. It's actually places where you can build engineering stuff and test stuff, put in fume hoods and that sort of thing. So that's part of it. They've also got now Outset Ventures, so for deep tech startups. So they've actually got money there that they can invest as well. And then the third one is around the ecosystem and the community. So that's sort of where I'm involved with Outset in Auckland. So in our Auckland events, we hold those at Outset. Look, if you're ever up in Auckland and you want to have a bit of a tour around, just give us a yell and I can take you through.
We build electronic products for other companies. We like to get involved when a product is going to end up in the field so that we can put some revision control around what we're doing. For those companies that have products that are going to be still used on the desk or just scientific experiments type thing, we can provide design for manufacture, design for test, design for sourcing information around that so that you don't end up with a product that you're trying to get into manufacturing which can't actually be built at any scale, or the test is a plywood box with a bird's nest of wires in it. We build products mainly industrial, we don't build consumer electronics. And I'm almost out of time. We've got 3 factories, one here, one in Australia, one in Shenzhen, China. And shipping from Shenzhen to the US is giving me headaches at the moment.
Awesome.
Thank you.
Thank you, Brent. Damien from Invenio.
Thank you. So I'll keep it quick. So the main focus of what we do is we supply software tools like SolidWorks, CATIA, Dalmia, virtual twins, AI tools. Our point of difference is all of our members in our team are experienced, qualified engineers, and we work really closely with customers to make sure they're getting the most out of what they're doing. And we also supply hardware, mark forged, strong end-use 3D printed parts. There's some samples at the back. Continuous strand carbon fiber printed plastic parts. Means customers can create end-use parts without supply chain. Quite innovative. My personal technology preferences are actually exploring all the emerging technologies. For example, we do things like virtual twins of factories through to virtual twins of human organs. So come talk to me.
Awesome. Thank you, Damien. I would like to thank our venues who are also supporting us tonight. First of all, thank you to the Chamber of Commerce for hosting our live in-person event, and also to the venues for our watch parties and in Auckland with Outset Ventures, and also in Christchurch with the Ministry of Awesome, and in the workshop in Queenstown. So if you're ever in those areas, please check them out. So now I'm going to have our first speaker, which will be Terry from 8360. Terry, could you tell us a bit about 8360 and what you guys do?
Very good. Hey everyone, my name is Terry. I'm the founder and Chief Everything Officer at 8360. And startup life. So what we do is we're an engineering hardware technology company. We are the developers of the Nova platform. We have a big picture of it. So this is a world unique, it's a VR motion simulator platform. And the idea is that, virtual reality is really cool. You can stick on goggles and they can take you somewhere, put you in the cockpit, put you in a car, put you on the mountain. But it doesn't feel like it. So if you're in the car and you're speeding around, often you get sick when you're trying to race in a chair. but also you don't feel the vehicle, you don't feel what's going on, you don't feel how it's handling, you lose that situational awareness, and your brain knows that it's not real, and so it ruins that immersion, which is really important, both to have an awesome experience, but also if you're trying to deliver training and develop skills, you have to actually be engaged with what's going on. This platform is unique because it is completely untethered. So you climb inside, strap in, VR goggles on, you've got a driving wheel or a flight kit, and once you hit go, it'll flip you completely upside down if you do it wrong, or if you do that on purpose. And so the idea is that you can put people in an experience and have it be that much more realistic and engaging, so you can use it to deliver safety critical training. And we've also found that people can use it for, there's a lot of different research applications that universities have come out. So the main thing is, you can put someone in a flight simulator in an aircraft, and it's following the physics of what comes out of the simulation. So depending on what the different vehicle is and how it's behaving, that's what the user feels and what they're seeing. And so you're actually taking them and sending them somewhere else without them going anywhere, which is quite cool. We set one up as a driving kit. So this is running Assetto Corsa with like a full direct drive wheel for a terrifying racing experience. I am bad at racing. That's a thing that I learned. And really, what's cool about it is that it's so compact and portable. So, you set one of these up, you can pallet jack it around in a shipping container in the back of a truck, drop it somewhere, and you have this multi-purpose immersive experience that you can take out to events, you can take it to different places.
Awesome.
That's our factory.
Cool. So can you tell me a bit how the Nova works and how is it made? Oh, could you tell me a bit about how the Nova works and how it's made?
Yeah, so as I say, the unit is completely untethered. So we have this, a metal frame that we build this shell around, and the entire unit is sitting on a drive base. So inside the ball, we have a full VR computer, VR headset, full PC build and batteries. It's completely untethered. There's no wires. Once you get in and shut the door, the entire cockpit will spin, flip all around, upside down, 360.
It uses wheels, right? Like in
so
the base.
In the drive base, we have 3 big meaty servo motors, 3-phase motors with omni wheels, the wheels with the rollers on the sides. And so if you arrange those in a triangle and sit it on top, you can get the ball to do roll, pitch, and yaw in all directions. I recently learnt that is called a Kiwi drive. I was not aware of that. And so we make this at our factory in Petone. My R&D engineering team is also the production team when we get orders and have to build things. Some of it's very expensive specialist kit. Some of it is just standard off-the-shelf parts, bits of PC and that kind of thing. We use a lot of local suppliers for metal fabrication and powder coating and getting bits. And we also have developed a lot of custom stuff because no one else in the world has built one of these, and it creates interesting problems to try and do that.
Awesome. So what has the journey looked like so far? And it definitely sounds like a journey from what you've told me.
It has been an adventure. So we started out back in the day in the corner of the Wellington makerspace, and this company really started as, it was an evenings and weekends beers project to build a contraption. It started off with us trying to think of something crazy to build, and we came up with this idea of a helicopter hover trainer because helicopters are really dangerous. They want to be upside down and on fire. And the hovering is the most important skill because it's inherently unstable. And we were looking at, this was in 2015, Arduinos were all the rage, and suddenly all the IMUs and sensors and other electronic, all of this stuff that was previously not really accessible, was suddenly you could go on SparkFun and buy it and set up your own kit, and there's lots of tutorials online. And VR headsets, the first consumer VR headset had just been released, and so we were slightly just looking for an excuse to buy one. Work-related tax-deductible research budget. They weren't available in New Zealand, so when one of my friends, Ravi, went on holiday to the US, we got him to bring one back in his luggage. But really it started off as, let's build a contraption. Yeah, a flight simulator would be really cool. But everyone else, that's been done. Everyone does the RAMs and things. How can we do it differently? And seeing that you can combine VR was suddenly available, and all the sensors, and realizing that we could do something new and something different. And it was really the challenge of, I wonder if that'd even work, and if we can do it. And so the first gen was very much a hack. We had no budget, it was founder funded, and so this black fiberglass monstrosity, which is where the 8360, the name comes from, because it was the 8-ball.
I love it says front, just so you know which part is the front of the ball.
Yeah, well, that was one of the problems with it, is once you shut the door, you can't see what's going on. Like, they're upside down, and it's very boring, which is why the second gen is see-through, so you can see them screaming. And, it was very hacky. We were doing this on a budget, taking apart bits of laser cutters and buying stuff from AliExpress.
Did you say the door, to open it is from, like, a car?
Yeah, so as you can see, there's some random electronics and Zigbees and stuff from SparkFun and things that I may or may not have misappropriated from my workplace. The door on the thing, it was really cool. We had these gas struts that we got from Pick Apart from a Corolla boot. And so the door, you hit the button, and when it opened, it went It was very shiny. Hardware is difficult, and it is, especially with something complicated like this, it is impossible to actually have enough resources and enough time to build what you're imagining. So very much iterative development of, how do you eat the elephant one bite at a time. So this first generation, it didn't have VR in it at all. We didn't really have any nice custom electronics to make it work nicely. It was a bunch of gel car batteries and a $200 mains inverter from AliExpress and a multi-plug. And so we just plugged a TV in and some lights and a computer, and that was all chill till the metal shavings got in it and it blew up a little bit. But we built this thing, and what we proved was that we could actually do it. Like, it was possible to do it, and that it did actually kind of do the thing that we thought it might. We had this vision of something doing something new, something different, and combining the VR and the motion and thinking, is this going to give you that realistic experience? Is it actually going to be greater than the sum of its parts? And even though it was fairly janky and possibly a death, no one died, but it was a bit of a death trap. It actually it captured, we saw the potential of it. So I ended up quitting my job and doing this full time out of morbid curiosity of I wonder what happens I wonder if we can make this a thing. How far can we take this? So in 2016-17, still founder funded, we moved out of the corner of Makerspace and into a nice leaky garage on the Callahan campus. Don't drill holes in the walls, it's got asbestos, that kind of thing. And we started on the Gen 2. Gen 2 was clear so that you could see the people. And we started trying to work out how to take out the car batteries and the mains and other things that were obviously a bad idea. So the second gen, we ran off a laptop, a gaming laptop with speed holes drilled in the bottom to make it go faster. And we had a VR headset, which was my phone tethered to a USB cable with one of those $20 Bobo cardboard VR headsets.
I love that.
And a QR code blue tack to your forehead, and a PlayStation 3 eye camera, because it turns out that they will run at 120 FPS, so you can use that to capture the VR tracking. So still very hacky, but slightly better than the old one. And what the idea was we've come up with this idea of a thing, but explaining it to people is really hard because it's something new. It's not something they've experienced before. VR is really new and unfamiliar to most people. The idea of motion simulators and kind of how you respond is not how you would expect yourself to respond if you've never tried it. So in order to actually prove to other people that this had potential, that it had value, we had to develop it to a point where it was actually good enough that people could get in it and try it and see it for themselves. Because the only way we could prove that it was something interesting or try to sell it to people was to actually have a thing to show them. So we continued developing. That one was interesting. It was getting closer to what it should be. It had VR, it had controls, it had the laptop. The VR was terrible and the laptop was terrible, and it kind of worked. Then we got kicked out of Callahan because we ran out of money and couldn't afford rent. And we washed up into the first assembly hardware incubator in Lower Hutt. And that was really cool because as we've said, when you're building hardware, you need facilities, you need places that you can make messes and make noises and have dangerous equipment and do your own three-phase wiring and other socially responsible activities. So we set up on the first floor above Pizza Hut, just over by Queensgate, in this like a 2x2 metre ball in a 3x3 metre office, and continued developing on this. And so this was the point where we actually had VR inside. We got one of those like $6,000 for a VR backpack computer thing that was actually designed. Gaming laptops are a lie. They have to be plugged in the whole time. They really don't like not being plugged in. We had to do terrible things to that to make it work. So this one, we got to the point where you could actually get inside and be in a proper VR headset and run a proper VR experience at more than 20 FPS. And that was the point where we could actually show people. And so we started, we invited NZDF in because we were like, you guys, you do lots of dangerous stuff. You have this big, weird specialist equipment. How do you do training for that if you're not actually destroying your real stuff? Is this interesting to you? Shopping it around to find out, because we realised that it could be more than a flight sim. It could be driving, it could be flying, it could be a spaceship, it could be all of this. But then we had to find people who actually wanted that. Mm. We had a better mousetrap. And so we started showing people around. And this was also the point where we actually had it developed to a point where we could raise investment. So we started going out to the investors and saying, look, we have this idea of kind of revolutionising how training is developed and is delivered, and we've got this new thing that no one else has, and we think that it has potential to be better than other people's. And so we raised the first not very much money in 2018, and we used that to move out of First Assembly when that got shut down and move into our own office in town, which was also leaky and condemned, but it was bigger. And so that was the point where we started on the V3, which was that, we've put enough effort into hacking this and doing horrible, terrible things to be able to show people and have them understand what the potential is. Now we need to make it not be crap, so that if we tried to sell someone one, they would not be very disappointed. And so we were still working with NZDF at that stage. They were really great, supporting us and giving us access to, we got to go on base and talk to the right people and learn things and get given a chance. And we had money to start bringing on teams so that we didn't have to do everything ourselves. And so we started working on the V3 and trying to do stuff a bit more properly, and get it to the point where we could actually, invite people in and show them this thing and have it be credible as like a real product. Then we raised a bit more money and we got our office in Petone, which we're still in now, which is only like really slightly leaky, but not really. It's good. It's garagey.
It's a classic startup founder with the candles.
Other people wear PPE and are responsible adults. Honest. So we got this office and we started building real production units. We were prototyping. We had a laser cutter. We could cut out some wood, turn them into metal, like a real boy, and start lining them up. And this V3. We were trying to lock down the design to be a production unit that we could replicate, except that there was always things that we wanted to improve and always, there's never enough time and money and things. So we've been iteratively, over the last 5 years, we've continued to develop and improve and refine this product, but the design really hasn't changed. It's just a better door hinge, a bit of this, a bit of that. Yeah. And so we've been building and selling these for 5 years now. And that was the point. So being able to actually have our grand international launch of we're going to start selling these was planned for the 19th of March 2020. We went into lockdown on the 17th. Brandon started his first day of work on the 16th. He turned up and got handed a laptop and told to go away for 3 months. But that, having a product that we could actually go and take outside has led to a whole bunch of interesting adventures and hijinks. This is the team in Dubai. I got an email in the spam folder of my personal email address at one point saying, "Hi, I'm a tech scout. Your tech looks interesting. Would you like an all expenses paid trip to the biggest tech show in the world?" And we're like, okay. So that was how we ended up at the GITEX Tech Show in Dubai next to a robot coffee maker and Uber's flying car, and how the boys spent Christmas in quarantine in 2020. But that was pretty cool. Gabe Newell, the Steam guy, came to visit at one point because I emailed him and asked if he wanted to come over. Actually, I emailed him an invite to our launch party, but that didn't work out so good. That's Internet Centre. That's cred. We also possibly had the first Valve Index VR headset in the country. I got him to sign the box in a silver pen. That is a family heirloom. He came in and he's like, "These balls look like my submarine," which is a thing that people who have stupid money say is I have a submarine. I humble brag. Working with NZDF, we got a huge amount of access that you wouldn't really expect. We ended up, the whole team went on a convoy in their trucks around the Wairuru training ground. We spent a day just driving around in their trucks to learn, how they operate and how the trucks actually work and what their issues are, to build a training simulator for them to practice truck handling. It was really cool. We went to a massive defence simulation training conference in the US with space lights under the balls to make them look better.
Futuristic.
That was the first time in the US, and it was Florida. We saw alligators. We ate alligator. We got pulled over on the way to Cape Canaveral, on the way to the Kennedy Space Center by the Federal Space Police. It was interesting. And then we sold a unit to Dr. Greg, the space astronaut. So he's currently making space mission training simulators using the Nova, which is very cool.
Awesome. What is
Shenanigans.
Is this a video?
No, this is just neon space lights, smoke machine vibes.
Looks very alien. Cool. So in that case, what is you've done so much. What is the future shaping up to look like for you guys?
So it's been really interesting over the last 5 years, kind of exploring what we have as an enabling technology. It's a development platform for building so many different things and exploring what those things are. We're still working in the serious, safety critical training space, saving money and saving lives, and we think we kind of have a foot in the door to start to change how training is delivered at scale and, disrupt some people with our stuff, to prove we actually have a thing that is really cool and better than other people's, which is exciting. But we're still working, we have units in 5 universities now, and seeing the different things that they're doing with it and talking to other universities and finding out the different, from psych research to aeronautical engineering to astronaut space stuff, seeing the different things that they're doing with it is really cool because I'm an engineer and I just nerd out about things. It's good. So it's the adventure continues.
Awesome. And didn't you mention that, I think we talked about that, currently in the US there are some incredibly expensive flight simulators and stuff they have compared to what you guys are producing. So you are kind of disrupting the market significantly, right?
Yeah, it's gonna. So some of the simulators that they use in flight sim and other space, they're tens of millions of dollars. They're massive and heavy. They need an entire dedicated facility, and if you can take out even just some of the bits of that training that they can't do, flipping you upside down and making you fix it, spin out training, upset recovery, crosswind landings, things where you actually have to feel what's going on in the aircraft. I still reckon we have something. Mm-hmm. So we'll see how that goes.
Awesome. And last of all, is there anything the audience can help you with today?
Yeah, I was talking to people about this before. So one of the things that's really difficult is hiring in startup land. Everyone's competing over the same 5 engineers, but what we tend to hire on attitude and not just, your skill set or your training, but your other side interests, people who are really interested in VR, people who are interested in flight sim or racing and have other interests and skills that are relevant to us because that knowledge is really useful. And more than anything, the best hires we've done are from referrals from other people in our network. So rather than actually posting jobs, I tend to just stick up messages on LinkedIn saying, we're looking for an X. Does anyone know anyone? Send them to us. So if everyone can follow our LinkedIn and send us people next time, so I don't have to pay LinkedIn $100 for a bunch of uselesses, that would be nice. Thank you.
Perfect. Awesome. Thank you very much, Terry. All right, now we'll do our Q&A with Slido. Has the scuffing problem on the plastic ball from drive wheels been solved?
Yeah, I guess this is one of the interesting things, is when you do something new in ways that other people haven't done it, you end up with all these weird problems that other people haven't solved, which, you know, is IP that we have. So we've explored different materials, working with suppliers to try and get them to make the things right. We've changed control systems and algorithms and worked with the physics, and we've done a lot of work to reduce the scuffing, because when you drive crazy, the wheels scuff the ball up. A lot improved. However, we've also worked out that we can buff the scuffs out, and the Buffy kit is now consumables. Yeah. Business.
So what's next? Do you see manufacturing scaling in New Zealand?
So in the short term, you know, we're building in the factory. We could scale up manufacturing here. We're a high-value, low-volume product. I don't imagine we're ever going to be trying to churn out 1 million of them, and so we're not going for that minimum price point. If we were going to move manufacturing and scale up, it would probably be because it was more practical. I mean, shipping them from here is ridiculous. We spent $60,000 to air freight one to the US recently. That was the first one that's been air freighted, and that bill has definitely got sticker shock. In the short term, we're keeping it here. In the longer term, you know, once we stop changing the thing, we might be able to outsource it to someone, but we keep fiddling it. So that's an open question, that one.
Any product cleanability concerns arising from passengers or victims with weak stomachs? I wouldn't be very... Oh, yeah, I'm going to actually go on the simulator tomorrow, but hopefully I won't have that issue.
Say some famous last words. Before and after. So we have never had anyone vomit in the ball.
It's always time.
Oh, yeah. Famous last words. One of the things that's interesting is when you're in VR and you're racing a car or flying a plane, because it looks like you're moving, it's all around you, but your body knows that you're not, that makes you sick. And so when you get in the ball, we often have people say, I actually feel less sick. I just feel slightly scared for my life, which means it's working. We also, you know, you're on comms with people, so we tell them, if you feel sick, get out. Here is the panic button that you can press. We let people get out again. Yeah.
How long did it take to put the panic button in?
We added that on the 3rd gen. I have a fond memory of putting Justin Lester, the mayor, into the previous one, and him saying, "Where's the emergency stop?" And me being like, "Oh, if you just yank all the cables out of the computer, eventually it'll stop." He went in it anyway.
It's a test of testing in a simulator if you could physically do cable work, right?
Yeah.
Are you worried about shipping to the US with the tariffs?
That's going to be an interesting one. I don't know if you know this, but manufacturers don't actually pay the tariffs. That's someone else's problem. So we will see how that goes.
Do you feel acceleration in the product? If I'm in a reading car simulator and I put my foot on the accelerator, do I get pushed back in my seat?
Yeah, so because you're inside VR and you're cut off from what's actually going on, it allows us to do some interesting stuff and mess with you. So, you know, if you're on the runway and you hit the gas and take the brakes, or if you're in the racing car and you hit the gas, we can tip the entire thing back, but your view of the road also tips back. So what you feel is we're misusing gravity in ways that it's not intended. So you can feel the acceleration, you can feel as you're building up speed and weaving down the runway, you tip more and more, and you can start pulling in a lot more physics. Because we have this full range of motion, this envelope to play with, you can simulate a lot more of the sensations and the physics. And it's interesting how much, like, engineering is how stuff works, and biology is how stuff works, squishy edition. And so it's really interesting exploring how much you can mess with people and trick them, and how much your eyes are like 95% of how you know what's going on. And so as soon as you're seeing something and if you just get shaken around, you still think that's what's happening. So that's really cool, is these shortcuts.
Last question now, so everyone vote because they're too tied at 2 votes. Give it one more second. Can the simulate linear acceleration or only angular
Yeah, so that's the
velocity?
same one again. So that's the same as, misuse gravity, feels like speed.
Alright, I'll give one more. What was your inspiration? John Britton zorbed the Back to the Future car.
Honestly, I moved back home after 2 years of having my own garage, and I couldn't do Engineers are made to solve problems, and if there are none handily available, they will create their own. And so because I didn't have my own garage to do dangerous things in, I had to find someone else's to do it in. So, it was like, let's build a contraption just to kill time and see what happens.
Awesome. Cool. Oh, okay. I find this question interesting. What about compliance? Like, how do you navigate that with no one, with no applicable one potentially? Yeah, with compliance.
It is very difficult trying to get a straight answer from people about what even it is that we are supposed to do about it. So that's an ongoing battle. Some places it's easier than others. Some places the rules are more clear, or they kind of carve out exemptions for you sell less than 10 in New Zealand, you don't need X, Y, and Z. But yeah, it's not easy.
So thank you very much, Terry, for your talk today. It was amazing. Cool. So next up, we're going to have Bradley. Thank you very much for joining me today. So could you tell us a bit about what OpenStar does?
OpenStar is a energy startup, so we're looking to do fusion in the Noaranga Gorge of all places. Yeah, pretty much.
Awesome. So how does it work? How do you do fusion? How do you make things to do that?
So our kind of fusion scheme is, if anyone's heard of a tokamak, so a tokamak is essentially, if you have plasma, you can fuse. There's a picture of our team, 65 people at the moment, and on the right is when we first got our first plasma, and I thought it would be funny to make it look like I was dying. So back to the tokamaks. Fusion is essentially just making plasma really hot and trying to get atoms to collide into each other, and small atoms will release energy as they fuse. So in a tokamak, you kind of try to squeeze plasma using magnetic fields. It's kind of like squeezing a sausage. For us, we are kind of a levitated dipole, so instead of having magnets on the outside, we have a single ring on the inside, and it kind of follows a dipole magnetic field. So the Earth has a dipole magnetic field. If you've ever seen the auroras, that's essentially what our confinement scheme is. So if the Earth had a hole in the middle, that's essentially what our magnetic confusion scheme is, and would have fusion right in the middle of the Earth, but instead we have the Earth and we get the auroras. Yeah.
Awesome. Do you have any pictures of that kind of stuff?
Right at the end, we'll go, yeah. Unfortunately, I forgot to add our LinkedIn post, so there is a video which looks much cooler, but in the middle there, what you can see is our magnet, and there's a faint kind of blue glow that is essentially our plasma. Yeah.
Awesome. So, because you mentioned before, so you have to manufacture individually a lot of the stuff. So, what are the kind of things that you guys manufacture?
So, what we make is superconducting coils. So, a lot of our tech comes out of Robinson Research in the Hutt Valley. So, superconducting coils, which we build into a structure, and then we have to build our power supplies that supply the current into that magnet. Kind of everything mechanical around the system. So, that shell there itself has the magnet housed inside, the vacuum chambers that we have to build. So it's like a really large oven, essentially. So there's not very many places in New Zealand that build vacuum chambers the size that we need. So we went up to E-Tech in Palmerston North, who make really big milk vats. So that's where we got our vacuum chamber from. Had to be put on a trailer and shipped down from Palmerston North.
Such a New Zealand thing to use a milk vat.
Exactly. Yeah, so those are the kind of things we make.
Awesome, cool. So what does the journey look like so far?
So at the start, we were kind of a company that was like, build it, break it, and try again. So we ran kind of like 12 months doing that. Built a whole lot of magnets within the first kind of 8 months. Built our power supply technologies. So our magnets are relatively high TRL, so they're relatively understood. What was really difficult was actually the power supply tech. So a lot of that work came out of Robinson kind of around when I was there. And it was kind of a laboratory kind of deal. So we had essentially a polystyrene box which you would fill with liquid nitrogen, and you put something in it, and you hope that it works. You cross your fingers, don't look at it too hard, and it will kind of drive the currents that we need to power our magnets. So really the challenge was trying to take that out of that kind of polystyrene box and make it something reliable and does what you think it will do. Yeah.
I think you mentioned when we talked that the biggest struggle you were having was like integrating everything together, right?
So yeah, we're probably a little bit hubrisly at the start, but like 12 months, we'll do that. That's not, can't be that hard. Hardware is hard. So there are a lot of technologies that go into this thing. So there's electronics, there's a lot of mechanical engineering, there's a lot of kind of very low TRL technologies that needed to be scaled up into something a lot more reliable. So yeah.
Cool. And yeah, so what's the future looking like? Like, what are you pushing towards?
So last year, so exactly Halloween, because that's the only time we ever do anything. So our vacuum chamber arrived on 2023 Halloween. We got our first plasma Halloween last year. Hopefully we'll do something Halloween this year as well.
Do you also dress up at the same time?
We have photos. Silly things written on people's heads.
Yeah.
Sorry, what was the thing?
So yeah, what is the future shaping up to look like?
So this is kind of our integration prototype, showing that we kind of know what we're doing. We can put things together, and we're not just like some random group of 25-year-olds in the Noronha Gorge trying to do something. This is a levitated plasma. So it's supported plasma. While it looks like it's levitating there, it's actually being held up by a mechanical assembly. So our kind of final milestones for our seed milestones is to essentially get that levitating. So that's kind of short-term goals, and then kind of longer term, it's essentially to push the performance of our devices so that we can show that the scheme is capable of doing fusion.
So what do you have to do to get it to the point that it can levitate? That doesn't sound like an easy thing to do.
So there's a couple of things. The power supply tech itself, we've shown that it works, but essentially the performance isn't good enough, so we need to push that up. It's about like 100% more, which sounds quite a lot, but we're really close, promise. There is also, it's kind of faint at the top, but there's like a little ring at the top. There's another magnet up there that's providing a magnetic suspension force. So we're in the midst of building and QAing that. And then safety systems for our plant. So it's relatively safe for people, but if in the event that someone presses the wrong button or put in a minus sign somewhere they shouldn't have, we'll catch our multi-million-dollar magnet and hopefully not damage it too badly. Yeah.
Something I wanted to dig into a bit more is I think when we talked before, you mentioned like, yeah, integrating everything together was always like quite a struggle. And like, how did you go about like getting past that?
At the start, it was kind of like everyone kind of had their own project that had a predefined boundary, but no one was really looking like on top of those boundaries. So there was always systems that didn't quite understand what the other side was trying to look at. So probably 12 months ago, we introduced a technical review board just to help catch those things so that when teams are bringing things together, you know what one team is expecting to have on the other side and what you need to hand off to the other team and what you need to have tested before the other team receives what you want, what you get. That really helped a lot, yeah.
Cool. And is there anything that the audience can help you with today?
Same as Terry, we're fighting with the other four engineers. We have job ads up, so there's a mechanical engineer, technicians, stuff like this. Yeah, pretty much.
Awesome. Cool. Thank you very much, Brad. Now it's my favorite time, question time.
So this is kind of the conceptual idea top left.
The bottom left one looks like it's on fire, but that's just my...
It has been on fire.
That isn't on fire, is it?
But not that particular one.
Cool.
So this is kind of the power supply tech that I was talking about. The top left is really conceptual ideas of what we were thinking of making. So essentially, it is a transformer rectifier, if that means anything to anyone. We take a little bit of current on the primary side, and we scale that up really high. And we pump that onto our magnet. So it's kind of an overview of the relative slapdash, put things together mentality. And you can kind of see there's a million wires in the top right, trying to just get the damn thing to work. And then slowly over time, we figure out what is the crucial sensors, and we take things out and clean things up, and it gets better over time. Again, same story with this. This is our electronics. So we had a lot of power drives at the start that we needed to build, blew up a lot of them, figured out what was wrong, increased TRL, integration stuff, make it smaller, tidier, easier to work with. And yeah, those are kind of the only two photos. Yeah.
Awesome, sweet, thanks. What does the pathway from plasma to sustainable fusion look like?
So for us, it's really about scaling the performance of our technology. Right now, we are kind of taking a whole bunch of technologies that are relatively new, putting them together and showing that they work. So we've done that now. For our Series A, we're essentially looking to push that plasma performance. So a little bit of reference. Our magnet at the moment is 5 Tesla. We're going to go up to around 20 Tesla. That's kind of the magnet scaling. Kind of the same vessel, but trying to get a little bit of fusion for our next device. And then after that, it's essentially just how far can we push it until we get fusion scale.
Awesome. What's the next big milestone after plasma, after the first plasma?
So that's levitated. In that picture before, the magnet itself was supported, and we want to be lifting that up because that really impacts our performance. If anything touches it, you cool down the plasma, and it makes it really hard to get anything useful out of it.
What about after levitation?
After levitation is bigger magnets, essentially, 20 Tesla. Test out the plasma physics. There's a particular thing in plasma physics called the triple product, and if you can get to a high enough value, it means that you can fuse, and that's what we're aiming for.
Are you affected by the closure of Callaghan Innovation?
Probably for us, it's kind of our connections with Robinson. They are on the Callaghan campus, so some of that kind of existing research and connections that we have will probably affect us, yeah.
Is anyone else doing this, or just in Aotearoa?
It is just us, yeah. There is research around this particular device, but none of them have actually targeted fusion, I should say, yeah.
New Zealand's electricity supply is largely renewables based, with intermittency being an issue. Could this be one of the solutions long term?
Yes.
I'd like to hear that. What do you expect to be your duty cycle charging versus levitating times?
Great question. It's the bane of my existence. So for us, charging that magnet takes forever. So when we first tried to do that first campaign, we were there for a week trying to charge that thing. For a power plant, you can't just turn off your energy for a week. So we want to get that down to like minutes at most. We just never wanted to charge the magnet at all. Yeah.
Skills of your team versus university or industry experience. Are there any particular industries close to what you were trying to do, or a lot of learning on the job is needed?
I would say probably both. So there are obviously a lot of academics who have kind of absorbed into our team. There's like superconductivity that we just need because that's what we're doing. Some of our technicians, no academic kind of background, but like tool makers, people really good with their hands to make stuff. Sometimes, as me coming out of an academic background, couldn't put a thing together to save my life. But yeah, a lot of skills that we need.
Awesome. Do you need cryogenics for the levitated magnet itself?
Yep. So right now what we do is helium. So that's just a gas. In future we'll do a little bit more exotic things, but right now we're using helium.
Cool. Do you simulate the plasma in electromagnet before the physical testing itself?
We did that relatively early just to get a sense of the performance of our system. But yeah, we did.
Awesome. Cool, thank you. Oh, one more. What's your team doing different from other startups in this space, and where did this insight come from?
Ratu, my boss, knows someone from somewhere, and he was doing a PhD in the University of Tokyo, and they happened to have a smaller scale kind of device down the corridor when he was doing his master's in Japan. And that's where it came from, yeah.
Awesome, cool. Awesome. Thank you very much, Brad, for speaking to us today. Alrighty, now we're going to have pitch time.
Kia ora tātou, my name's Anita Perkins. I'm an independent research consultant. I like to help people solve complex problems and create meaningful change through research, people connections, strategy, storytelling, that kind of thing. I have two offers. One is one of my contracts is writing stories for the Asian New Zealand Foundation Media Centre. So if you would like you have some kind of connection there and you would like to look into a story for that, I could help. The other is I have quite a few connections with Germany, so if you're looking into researching or partnering in the German-New Zealand space, then hit me up. I'm happy to give anyone a card, have a coffee, or look me up on LinkedIn under Dr. Anita Perkins. Thanks.
Hi, I'm Jesse. I run Vivid Origin, a design studio here in Wellington. Firstly, David and Monica, thank you for bringing an event to Wellington, because we do complain that we don't get stuff here, and so we all turned up. I guess, yes, like I run a studio, but I wanted to kind of put out there that we're really well connected to the design schools here in Wellington. So if you are looking for students, whether that's for, different, especially in the kind of industrial design space or the kind of user experience space, really happy to help. And I guess we're just really well connected, whether that's manufacturing here or in Asia. We're just happy to share what we know when you're trying to accelerate what you're doing, because once again, hardware is hard. And so, yeah, we like to share what we've built up over the years. And so if you want to reach out and you want help, just let us know.
I'm Paul. I'm a mechanical engineer. Something that Terry said actually brought a thought based on, where I find myself. I've moved from Auckland, where I had a little bit of garage space, to Wellington, where I have zero garage space. So if anyone wants to pull me aside after this event and tell me about where all the maker spaces are here in Wellington, that would be great, because I might find myself visiting you guys at some point.
Craig joined me from Goodnature. Could you tell me a bit about what Goodnature does?
Yeah, Goodnature's a hardware company based here in Wellington. We started 20 years ago. It's a company that came about through a meeting. I met some good mates at university, studied industrial design and mechanical engineering, and we were set a challenge by a guy who worked at the Department of Conservation. New Zealand, as you guys know, is famous for trapping and pest control, offshore island eradication. We lead the world in that stuff. His challenge was, we have traps that go off once, we need traps that go off lots of times. If we're going to scale up this challenge, we need self-resetting traps, and he said, how can we do it? So we sat down one day, Sunday afternoon, Deluxe Cafe, Wellington, tried to come up with 50 ways of making a trap go off lots of times. I think we got to about 25. We thought of all the things: solar, batteries, wind-up toys, all sorts of things, rubber bands. Sometimes later, I was riding a bicycle with my daughter, and it had a flat tyre, and I waved down a mountain biker and asked him if he had a pump. He didn't. He had one of those little CO2 canisters. Borrowed it, pumped up the tyre, and thought, hey, this is pretty cool. We might be able to use this as an energy source. We were struggling with how to power this thing. So that kind of kicked off a process of product development, R&D. One thing that was really clear for us from day one is we had a really strong purpose and vision. We were really passionate about the environment, New Zealand, native species. We were, I think, a little bit terrified as industrial designers that industrial designers are famous for making shit that no one needs and ends up in landfill. That's a slightly cynical view, but we really wanted to do a product that had an impact and benefited New Zealand and the world. So we kind of jumped at this opportunity and started doing this project in our spare time. It had about I think, 2 or 3 year incubation phase of we were doing this at night, we were doing it in our own time. Then we secured some funding from DOC. They had this thing called the Innovation Fund, which sadly, no longer exists. A lot of those government departments had those funds that were for these speculative projects, slightly high risk. Hey, let's go out and engage with industry and see if we can solve these problems. So they did that with us. We came up with a bunch of prototypes, started developing, further development. A little warning, there's a few dead animal pictures, so for those who skirmish, my apologies.
Yeah, so
This is where it started, in a garage on Webb Street in Wellington. We were running another design practice at the time, so that was kind of funding this work. We started from, where did it start? So we had this idea of compressed gas. Didn't know anything about compressed gas, so we had to go off and learn about things. Learned about where the CO2 is used. It's in life jackets under every seat in every plane in the world. It's in fire extinguishers. You guys know where it is. It's kind of everywhere. Went to Bunnings and bought a nail gun. Learned how that worked. Learned about regulators. Learned about seals. Learned about all sorts of things. And very quickly, being a couple of years, we came up with this prototype. We started testing it. Started killing a whole bunch of stuff. We spent lots of time in the field. We spent lots of time in the Rongorongo Valley testing, killing lots of stuff, trying to video things, cutting up animals, trying to learn about the biology of animal behaviour, how they move in the environment, how to kill them humanely. It was always a really big thing for us. So yeah, that's what we did. So this is where we started. Wooden prototypes, everything was handmade. We had no money. It was just whatever we could get our hands on, we would kind of beg, borrow and steal from other industries. I talked about nail guns. I talked about scuba diving. We bought a whole bunch of paintball guns, had paintball fights in the office and then tore them down and worked out how they worked. This is us in the field, testing, trying to learn, camping down in Fieldland. Lots of fun adventures out in the field. That was one of the biggest kind of highlights of the project over the last 20 years. Getting out into the New Zealand forest and learning how this stuff works.
So could you tell me, how exactly does the trap work? How do you make it?
So
how it is now after that whole process?
The trap is powered by disposable CO2 canisters, high pressure. Goes through a gas regulator, regulates that pressure down to a really low pressure, a manageable pressure, and then it's got a relatively complex sequence of valves in there. And so that releases some stored pressure, fires a striker, just like a nail gun, kills the animal instantly and humanely, and then that dead animal drops to the ground. And once it's dropped to the ground, a couple of things might happen. It'll get eaten by another animal, or it will just rot away. Trap's reset, ready to go. It goes off 24 times. So you can set this thing in the field, come back 6 months later, and it will have killed lots of times. As far as I'm aware, the record is about 26 kills in 6 months. So and that can happen really quickly, particularly when you've got environments with lots of pest species. So yeah.
Awesome. You've told us a bit about the start of the journey. Could you tell me a bit more about the journey as well?
Yeah, the journey...
To where you are now, exactly.
So the journey started with 3 of us in the garage on Webb Street. When
was this?
Robbie, Stu and I. When? 2006, 7? Yeah. It's evolved to... We've developed 15 products in total. We now export to 42 countries. We're in 5,000 retail outlets around the world. 80% of our stuff is exported. We're really, in saying that, we always had a quite strong commercial strategy to break into global markets to help fund and support New Zealand ecology. There's very little money in New Zealand ecology. It's really hard to run a trapping business, a manufacturing trapping business in New Zealand, just selling to DOC. It's impossible. So we quickly realised that if we could take this tech we've developed and these processes and this knowledge, because in New Zealand, we're really, really good at it and we're highly respected globally. So we go into other countries and tell that story of what we've learned and our product, and people are always pretty keen to learn. So we've done work. We did some work with the Swedish government on an invasive species up there, mink. that were hammering their seabirds on the little islands up in Mink. We've done some work in Hawaii with mongoose, similar problem. Every country has the same story as us. They had a problem, they introduced an invasive species, thought it was a good idea. That pest went berserk, started killing all their native species. People freak out and go, oh shit, what are we going to do? Too late, the species die. So we're on the cusp as a country, as a world, of losing so many of our native species. So this project, and it's still a project, is trying to find ways, toxin-free ways, humane ways of eradicating native species to allow, invasive species to allow native species to flourish. And so we know it happens really quickly, like within a year or two. We take out the pests and the native species just go crazy.
Just like, for example, like a stoat, like
Yeah.
how long does it take them to like reproduce? Like,
Within, they're constantly reproducing, but what they do is they reproduce, they have their young, and then they disperse, and then it happens again and again and again. So it's this big snowball effect. It gets out of control, and so, but again...
How do you stop like it not like killing like the native animals, for example? Like, what do you do to make sure it's only like pests that get into the trap?
Well, we do a couple of things. One is the lures we use, so they're not attractive to native birds. The other thing we do is put them up high, where we have kiwi and weka, because they can't climb very well. Sometimes they'll be in enclosures to stop other things, like kids getting into them. There's a few little tricks we do. Yeah.
Awesome.
Yeah.
So, video?
This is our production line in 2008, and this is it today. So we're doing from a hardware perspective, we're doing all production in Wellington. So we have a production team of 16, 17 people. Everything's made in New Zealand, apart from a few things that we just don't make in New Zealand, like seals and CO2. Electronics are made in Australia, and then we bring it all in-house and assemble it and ship it out around the world. The goal is to start manufacturing in market. There's been a few questions around tariffs. We're thinking about that. It's still a wee way away, but ultimately the goal is to have manufacturing here in New Zealand, manufacturing in Europe, and manufacturing in North America. But it's a wee way off, but that's the goal.
Yeah, the other day I got lost in Wellington and I ended up in a random industrial area and I walked past Goodnature's office and I thought I was like,
Yeah.
I know them.
Yeah.
Cool.
Yeah. This is just a bit of a timeline. Does this pointer work? Yeah. This is our first product. It was a real disaster. We released it. We very quickly learnt that it wasn't right. And on one hand, it was a disaster, and on the other hand, it was the best thing we ever did, because we learnt so much from it. We learnt what not to do. We learnt the bits that were working. We worked with some great partners. We met a whole bunch of people. We formed some really strong relationships that continue to this day. We made a really critical decision to either, we had an option to try and patch it and fix it, or to make a big leap and make this new product, which is the A24, which is the rat and stoat trap, which to this day continues as our kind of hero major product. There's been a whole lot of kind of innovations along the way. This one here, this little silver funny little bag with the 10-cent coin on it. We made this trap that lasted for 6 months in the field, and we very quickly realised, somewhat stupidly, that the lure doesn't last that long. And so we had to come up with a way of dispensing lure, fresh lure, every day for 6 months. So we came up with the automatic paste pump, which is a 3-layer bag with paste on one side, the lure on one side, and on the other side there's a little battery cell, which is we call it a hydrogen generating cell, which is a hearing aid battery, which is repurposed and shorted out so it generates hydrogen at a very slow rate. So it inflates the top bag and dispenses lure out of the bottom bag for 6 months. So we overcame that. So you can deploy these things, and there are thousands of these deployed all around the world, tens of thousands, that literally will be just ticking away for 6 months at a time. Yeah. That was a really fun project. Callahan has come up a few times tonight. Callahan helped us hugely with this project. A couple of people there that we probably wouldn't have pulled this off without them. Understanding materials, understand how a hearing aid battery works, all that stuff. So just a big thanks to Callahan in general. They've been hugely helpful to us over the years. Evolution of putting it in a box so you can't see it and people can't steal it. There's an app, there's a little Bluetooth cap that can tell you when stuff's gone off, give you a bit of a history. we've got I've talked a lot about pneumatics. Last year we released our first non-pneumatic trap. So it's a new mouse trap, fully electromechanical, rechargeable, talks to your phone, been used a lot in domestic environments, but also commercial environments where they have, particularly in places like food environments where you can't use toxins, hospitals, buildings, but also primarily in homes. Yeah.
Cool.
All right, this is the video, isn't it?
Yeah. Let's see if it works. That's it.
Do any of them have like cameras in them or anything like that?
No, they don't have cameras.
Oh wait,
on
no,
them.
sorry, no. I have some context here. I have been battling a rat that has been stealing all my like gigantic tomatoes I've been growing in my garden, and I don't like. It's never caught anything, and I want to know like has he been nearby? I don't want to see anything. I was terrified to look inside, but every time I was disappointed. So yeah, no kind of surveillance kind of stuff yet, and that sturdily.
We do it from a research perspective. We use lots of cameras, but not for the customer. No, no.
Okay.
But it is something that's coming up a lot, particularly in ecology, where as we get to zero pest 2050, it's going to become really important for us to monitor and understand what's left.
Yeah.
And so we have got this. There's going to be this point where we go, there's not many left. What are they? Where are they? And how do we monitor them? And there's a lot of AI tech coming that's going to help us with that, which is really exciting. Yeah.
Well, my bit of feedback is rats really like tomatoes a
Oh,
lot.
that's interesting. That's good. Yeah.
They like rip them off and then run away with them. Anyway.
I'll skip through this. Yeah, this is our goal. We want to kill 100 million kills by 2030. We're trying to get rid of toxins around the world. We know the impact toxins have, particularly in New Zealand, in waterways, to our soil, to our all sorts of different species, biokill, making stuff sick. We want to provide tools that mean that you don't have to use toxins anymore globally.
Cool.
Yeah.
So this is what your future is up.
Yeah,
is
you asked
looking
me
like.
that future question,
Yes.
and I wanted to share this with you. We have been working for quite a while on this. We call it the A1, which is the aerially deployed biodegradable single-use trap for rats and mice. This is a very large-scale aerially deployed single-set trap dropped from a helicopter or a drone at very high densities at landscape level, so like tens of thousands of hectares, to eradicate rats, mice, and hopefully one day stoats. It'll go off once, and then it will biodegrade with the pest into the environment and disappear forever. So that's something that we're working on, and hopefully in the coming years we will be able to get those out into the field and do
Awesome.
yeah.
And is there anything the audience can help you with today?
I think the hiring thing's a big one for us too. Yeah, it's like
4 engineers, where are you?
Formway. There's a gag at work. There's only 3 left, and half of them are from Formway or you guys, or we keep hearing this all the time. And I think I keep hearing about people moving to Hamilton or Palmy or something. So just sing out if you hear of anyone. Yeah, that's right. Yeah, come to Wellington. Yeah. The other big ask I would have is, this product is really exciting. It's also really challenging. We have a massive materials challenge ahead of us. We're trying to make a spring, essentially a spring, that is biodegradable, is really easy to manufacture, and can stay stretched for a really long time. And physics tells us that's really hard. So if anyone knows any organisation, has any links to anyone around the world, we've talked to universities, we've talked to the big multinational chemical companies. They all kind of say, yeah, you can do it, but they never tell you how, and they don't have any data to support those claims. So it's a big hurdle for us, and we know we can solve it. We just don't know how long it's going to take.
Yep.
So, and when we do solve it, it's going to be a massive unlock moment for us. So, if there's there's any big brains out there that know how to do that.
Any elastomer enthusiasts?
Yeah. Come and see me. I'd love to talk to you. Yeah.
Awesome. Cool. Thank you very much, Craig.
You're welcome.
And now on to Slido. So please upvote. Are there any plans to introduce any IoT tech? You did talk about Bluetooth connection already.
There's a little cap that goes on the top of the trap which records kills. It records temperature. It knows when the lure's been put in and the gas. So, but it's Bluetooth, so it sends a message to your phone when you're in proximity.
Mm-hmm.
We're working on some more remote connected devices where you can sit on a dashboard remotely and say what's going on in an environment. That will be really powerful as far as understanding workflows for people that are undertaking these large-scale pest control projects. So that's something that's in the works.
Awesome. Why not attach a larger canister?
Yeah, we can. As soon as those canisters get bigger, it triggers a whole lot of other compliance issues. They get really, really hard to ship, borderline impossible, and there's not a supply chain for those larger ones. So we always think about our canisters as the AA batteries of gas canisters. They're in every bicycle shop in the world. As soon as you go bigger, you just can't find them. And the cost of them far outweighs the benefit. Yeah.
Being that accessible, yeah.
Yeah.
How do you target a specific pest?
So in New Zealand, we're really lucky because anything that's going to stick its head up there, we want to kill. Rats, stoats, hedgehogs, and mice, we're really lucky in New Zealand. The things that we don't want are the birds. And so we do that, like I said, by elevating it. But also, we've got a little blocker, which I didn't show, which keeps our parrots out, our kaka and our kia out, but allows everything else to get in. But we also can do it with lures, so we can put stuff in lures that birds don't like.
My own personal question, like what do they like in lures? Like what do they look for in the sense?
They like the same as we like.
Oh.
So energy-rich foods.
Tomatoes.
Tomatoes. Yeah, chocolate, sugars, oils, fats. Stuff like that. They just want to keep alive. They're looking for food. They're looking to reproduce, and they're looking for shelter.
Yep.
Yeah. So you want to try and understand. Weirdly, you start to understand how a rodent works.
Yeah. Is there some kind of studies about the best place to put it then in that way about considering shelter or what particular places they'd be more likely to look for food?
Yeah, there's a couple of things. They always say the best lure for any species is the food they're already eating.
Oh, okay.
So we do quite a bit of work with orchards, and they might have macadamia nuts,
Mm-hmm.
and we say we'll put the macadamia nuts in the trap because they're not going to change their food preference. So just catch them with what they're already eating. It's a bit like us in McDonald's, right? We just want to keep eating McDonald's.
Yeah.
But as far as sites go, they don't like being out in the open. Put them in corners, put them in the forest under trees, that sort of stuff.
Cool.
Yep.
We use your product for pest control on our trap lines. Any plans for possums and deer? That deer might be a hard one with that little canister.
Yeah, deer's hard. We don't want to go too big for obvious reasons. It gets into some pretty sketchy territory. And even possums. We had a possum trap. It was, I don't know if you remember the image, but it was the second product we ever made. It was very early on. It had some we couldn't upgrade it to fit all our new tech, the automatic paste pump, the Bluetooth thing. So we phased it out. We had intended to, and we still intend to make a new possum trap. It's in the works. It's coming.
Cool. What were the challenges you had to overcome to get an up and running unit until now?
Get up and running. Oh, until now. Everything. We talked about compliance, understanding global compliance. Obviously the technology, manufacturing, quality, people. People's always a big challenge. But also, I think the big opportunity, trying to understand how our teams, getting our teams humming. Innovation, trying to think about what's next. Manufacturing in New Zealand's always a big challenge, at a good price point. We've got tariffs coming. What do we do about that? It's always a challenge, but I think it's also the reason we do it. It's really fun. I'm still learning. And it's sort of a cliche, but it's just every day there's a new challenge. We don't know how to do something right. How do we do it? I would say on that, I think I was telling you when we talked this morning, I've called hundreds of people in New Zealand and asked them all sorts of dumb questions, and I'm yet to have someone say no. So I'd encourage anyone that's on this path to just don't be scared of picking up the phone. Don't send emails. Just pick up the phone. Ask a dumb question. Like, I think people just want to help. So I think that's the big thing. And there's just been no end of help from individuals, but also Trade and Enterprise, Callaghan, all sorts of different agencies. Yeah.
Awesome, great advice. Why a plastic spring? Metal should rust and degrade. More context, please.
Yeah, great question. I totally agree. And it's on the list. It's probably more about perception, and it's probably more about how it does degrade and what happens to it when it does end up in the environment, because a metal spring will last, depending on the environment. It could last, we go out to the bush today and find nails that are 100 years old. We don't want, but equally you put it in the ocean, much quicker. So yes, of course, you're kind of right, but it's not quite that simple. We want to avoid that. We want this, if we're going to lay out these things in the millions, we don't want millions of springs. You put a spring in central Otago where it doesn't rain, it will be there in hundreds of years.
Yep. I don't know why this one is bright green.
This is my question. I upgraded it.
Oh, okay. Where do you sell around the world, and what % of sales come from where?
80% of sales are offshore. We sell into 42 countries. We have around 5,000 retail doors in the world. We have a couple of different. We have a couple of big groups. We have ecology. So ecology is obviously primarily New Zealand, but it's also, we do some work in South Africa, Madagascar, Patagonia, Hawaii, northern Sweden, and that's all ecology. Primarily government funded, sometimes privately funded by rich individuals that want to eradicate an island of pests because they've got a resort on it. Then we've got PCOs, or professional pest controllers, and they're running big projects for private companies like universities or hospitals, those sorts of things. And then we've got DIYers, mums and dads, going down to the hardware store, buying traps. So there are three big kind of user groups.
So we can go down to Bunnings and get one of these?
Go down to Mitre 10 and get one.
Mitre 10.
Yeah.
Cool. How do the multi-use traps dispose of the dead pests?
So they drop to the ground, and they either, what we've found is within a couple of days, they'll be gone. And usually from, they get eaten by another animal. Yeah. So whether in New Zealand, that could be a moorpork, it could be a pig, could be a rat, could be a stoat, could be a cat, could be anything. And if it's not eaten, the maggots will get it and it'll be gone in a week or two.
Really?
Yeah.
Because I guess there are other things besides the pests that eat them, but maybe with some of the pests declining as well, that might reduce cleanup. But yeah, if it's a week with maggots, then that's not even much at all.
Yeah.
Oh, interesting. Could we get rid of the spring question, please, David? What's the story behind the 10-cent coin?
Oh, the 10-cent coin, it's got a little magnetic switch in there, so we needed something to turn that magnetic switch on and off. So we started with a little bit of metal, obviously, and then we realised that we're going to send hundreds of thousands of these out into the field, and that little bit of metal is going to end up in the bush. So how do we stop that? And we were thinking, how do we give that little metal thing some value? We're like, I don't know, how do you give a metal thing some value? And then we thought, let's just use a 10-cent coin. So we buy, probably shouldn't say this, we buy a lot of 10-cent coins, and we export a lot of 10-cent coins, which is, you're not supposed to do that. So I'm waiting for the call one day when someone says, you guys have to stop doing this. There is another, a flip side to that, though, upside to that for some of our community groups is the people that put out these, you might put 100 of these out, and by the end of the day, you've got $10 of 10-cent coins in your pocket. It's great for kids. It's also a great New Zealand story.
Absolutely.
People in the States love it. It's a story we can tell. I don't know. It's just fun. Yeah.
How to stay price competitive with existing DOC 200 and maintaining cost?
There's two costs to a trap. There's the capital cost. You've got to buy a trap, and then you've got to maintain it. And you've got to walk there, obviously. We're always trying to bring the cost down of our products, not just through the capital cost, but the maintenance cost. So keeping them going. We want community groups to run hundreds of these things. We know that DOC 200s are a lot more expensive than our traps to run, because every time they catch something, you have to go there and put new lure in it. Every time we go there, we can catch up to 24 things. So we're always thinking about price per kill, which is gruesome, but it's how we measure impact. And so when we think about landscape scale pest control, how do you get price per kill? Because there are tens of millions of pests in this country. How do we get price per kill down? That's the goal. And so we know we're a lot cheaper than a Doc 200 on that basis. Yeah.
I have a question in terms of, have you patented any of this kind of stuff?
We have about 40 different patents. So design registrations, patents on some of our triggers, all sorts of different formulations, lures, electronics, yeah.
Cool. But have you painted the, I don't know if you can, about using the canister?
No,
Yeah.
no, because it's old tech. The other thing that happened, and we made a mistake, we didn't have any money, so we couldn't afford to do the patent loop. You can go on Alibaba now and buy one of our traps made in China for about $40. Looks identical. I've seen some of the parts. I can't tell the difference. And so we missed that. We made a mistake. So we're pretty good at that now, going through design registration and key markets. It's interesting though, we've been ripped off twice. One by our Danish distributor, that was ugly, and one by a Chinese factory who we think used to manufacture for us. But they find it really hard because some of our manufacturing processes and our gas flow tech seems really simple, but it's really complicated and really hard to get right from a manufacturing perspective. And so the people that have copied us have really struggled. So patents are really important, but I also think even more important are not being scared of doing stuff that's really hard, because people get bored of doing stuff that's really hard. So it's actually one of our most defensible positions. Doing shit that's hard is a good thing for New Zealand. I think it's like doing stuff that no one else wants to do and doesn't understand, and we can put our national New Zealand brand and ideas and values onto it is a really high value thing I think we should be doing more of.
Absolutely. Are there other uses for the 6-month lure dispenser, like aphrodisiacs for Kiwis?
Oh yeah, I'm sure. I'm sure someone's tried it. Yeah.
Could you use audio lures in addition to scent lures?
Yeah, absolutely. Audio lures are really effective, particularly with cats and to a lesser degree possums.
Isn't it to bring them towards
To bring them in?
to
Yeah.
them? Oh.
The best thing to attract a cat, this happens a lot in Australia because they have a massive cat problem. The best thing a great thing to attract a cat is the sound of a kitten crying. Awful. But it's a distress signal and it'll bring other cats in from a long way away. It's a tool they use in Australia to control cats. And of course cats are a really big problem for them because they've got all these beautiful little critters on the ground that cats just destroy. So, like I said, every country's got this little problem, this challenge, and it's subtly different everywhere. So, makes it interesting.
What brings in a possum?
Possums, food.
Oh, okay. But in terms of audio?
Sound, different sounds and light and scent.
Okay.
Yeah. And also pheromones. Yeah.
Oh, cool.
Yep.
So do you use pheromones in like lures and stuff as well?
We don't currently, but we have in the past.
Cool.
Yeah.
Mhm.
Yeah.
Yeah, we already said that one. Yeah. Should have been paying attention. Over time, do pests learn/adapt to avoid the traps, like especially like a certain lure, I guess?
Yeah.
Could natural selection create limits on the success?
This is something I don't think the science is not, the jury's out on this. It could be, and that's why I think for New Zealand to achieve Pest Free 2050, one tool's not going to do it. We need a suite of tools. We need, probably the way this might end is a bunch of people running around the hills with dogs trying to find the last. So they could be. We've seen it happen. You can do things like change the lure, change the location, and usually it'll solve the problem.
Yeah.
Yeah.
What are the biggest challenges you had to overcome to sell internationally in the US and Europe?
Partners. Finding the right partners. It's really hard. And we've had lots of false starts. Well, not lots, a few. And also, once you've got partners, it's quite hard to change them. So you've got to keep them motivated, you've got to keep innovating and keep supporting them, educating them, trying to get them to live by your values so they represent the brand correctly.
Otherwise, they might go and copy exactly what you did and then try
Yeah,
to resell it.
yeah. Also to feed back to you and give you the insights. Like, what are you learning in the market? Because it's really different to us.
Yeah.
Partners is the hardest thing.
What is the funding/raising story like for you?
We got some funding from Doc early on. It wasn't much. We self-funded for a long time. We took investment from Gallagher Group in Hamilton a couple of years ago, 5 years ago. So they're part of the Goodnature family, which has been fantastic. Yeah. Nope.
Cool. Are the canisters recyclable?
Yep. They're steel, so you just chuck them in, get them recycled.
Awesome. Are there any ethical or cultural elements you have to deal with in the pest control process, either here or abroad, or are things pretty clear cut?
They're pretty clear cut, although in some groups they have certain ways of doing things. Yeah, but nothing major. Nothing that we can't, through good conversation resolve.
Awesome. So thank you very much for joining me, Craig.
You're welcome.
Sharing information. Okay. Thank you everyone for coming. It was really great to see so many people here. At first we were really struggling to find engineers in Wellington, but we clearly have more than 5 show up. So thank you so much for coming and telling everyone about it. Thank you very much to our watch parties in Christchurch and Auckland and Queenstown. And a big thank you to the Chamber of Commerce for hosting us tonight. Really appreciate it. And to all of our sponsors and other venues too. So thank you.